Believe it or not, a few of your classmates were in here for about hour and a half, 2 hours yesterday, playing with lots of these problems on the board. There are lots of places to get stuck. Sometimes it's at the very beginning, sometimes it's somewhere in the middle, and sometimes it's at the end about how to get the answer. But talking it out, bouncing it off of someone, and maybe having me nearby can be a helpful learning process, I think. So let's see how you guys did, at least as far as getting going. Right now, a single trig function alone. I wish, but I can't. Because they're not like terms, true? Basic math. He's not him. Oh. So what'd you do? You can substitute. Now, could you have made this one 1 over cosecant? Yes, but who likes cosecant more than sine? Not me. Did any of you guys like cosecant more than sine? Probably not. Especially since you were working in groups. If someone did go using cosecants, maybe the group was like, I think it'd be easier if. Do you have the courage? Do you have the compassion to be like, don't go that route? It's just hard. Slow down. Come back. Let's reorient. Well, there's wisdom to that. Let's just save that for the day. Okay, coming back. Now what? Yay! We want it in a single. Totally illegal. Until we do what? Yeah, I like it, Vanessa. Common denominator. Yeah? So then, hopefully, from all of our skills, you guys will multiply by maybe sine of x over sine of x. You get like 2 sine squared. Now, I'm not saying this is the only way. I'm curious in a second if any individual who hopefully got backed up by their group had another way, because there are a couple different things you could have done right here. But one of them is a common denominator. Ugh. Not in a single place. Even if you didn't do it my way, question this way, how could we keep going? Yeah. This has shown up over and over and over again this year. If division is messing you up, let's undo it by multiplying. Hey guys, what's 0 times anything? Oh, well maybe that didn't even make a difference. Maybe that division wasn't even supposed to mess us up. Maybe zeros only come from numerators anyway. No. -1 divided by 2. We're just doing like simple algebra stuff, right? Now what? What would the math tell us to do, technically, next, if we were to keep going? Yeah, because we get the single trig isolated, so we don't want a squared power, we want a single power, and single power is a square root, and a square root, hey, absolute value, plus or minus who? Put your brains together, you got this. What's wrong with that square root of the -1 power? It's imaginary. Dun, dun. I gave you a trick one. No possible solution. Why? I can't have sine being an imaginary number. That's not a thing. It's not at any real x. But do you understand the process I got there and why I got to a no solution answer? Here's a question. Did anybody have a different approach than a common denominator right back here? I'm not saying you had to. I'm just curious if you did. Did anyone go a different route than a common denominator? Okay, well, you trained well. Like, you're obedient. Because whenever you saw this before, you would have gotten a common denominator. So at least, like, you're remembering what we've done before. I just am used to... I don't want to put it that way. I guess more people thinking outside the box. A lot of kids, whenever they saw this, would have subtracted the 1 over sine x. Just kids in the past, they would have subtracted and then multiplied the sign and then tried to go that way. They would have tried to avoid the whole fraction thing altogether and been like, ugh, move it. Multiply it. Yay, 2 sine squared equals -1. Either way, it would have gotten to be -1/2, square rooted. Either way, it would have been no solution. But just a few people got around the common denominator in the past by subtracting and multiplying. But either way, common denominator, you were right. totally worked, got it all together, just this multiplying to the other side might have messed a few of you guys up, but then it's algebra of subtract, divide, square root, and say that's imaginary, so we're done. In some ways, why was this one easier than a lot of homework? What do we normally, we get to stop. What do we normally have to do? We normally have to go to step number 2 and use the unit circle cheater chart backwards and figure out what the heck kind of answers they want. But we got to stop here. Sadie. It's not a bad idea in the sense of like maybe we can avoid the whole imaginary thing. Can I just get a second page real quick? But if we did square root, my question isn't whether you could have. My question is how on earth you would have simplified legally. So not a bad idea at all. Thanks for bringing it up. Some people would have thought of it or even tried it. The problem is, remember, the only way to square root, or I should say the only way to simplify a square root is to be able to write this as a perfect square. That's the only way that that can cancel out. The problem is, if you go to factor this, though, it's not what a lot of people would have, well, you might have messed him up. It's not what a lot of people would have thought. Because if you tried to think that you maybe could just like square root each piece, remember, you end up with a whole lot more than you bargained. So even though we would love for a square root to be like multiplication and to be able to go to every single piece, it works with multiplication and division. If we were to square root something like 4x squared, we can do that piece by piece. If we were to square root 9/16, we could do that piece by piece. Multiplication and division, there is a distributive property of powers that works with multiplication and division. And I don't like that it's called the distributive property, but it is. But with addition and subtraction, it completely falls apart, and it's completely illegal. So there is no perfect square that I can go in for. And technically, the way to get the factors, if you remember, factors are zeros. So if we did want to try to factor this guy, we would have to put in we would basically have imaginary zeros. So we would have plus and we would have minus and we would have like root 1/2 I. So way back in like chapter 2 with nasty polynomial factoring, like we would have actually written factors, but number 1, it wouldn't have been a perfect square, and number 2, they would have been imaginary. So all that to say, I get why you tried it, just killing a puppy was the only way to go for it. Any other questions about like what you tried or what you did or what you thought you could do or where you got stuck that my solution or my way forward didn't answer? Emma.
If the 2 was on the inside of the sine x, how would you get rid of it? If it was sine 2x?
Okay, this is laughing too. Do I not have any? I mean, I do. I had the one from yesterday. Okay. Right?
Yeah.
Okay. Right? Stuck. So I need to do inverse cosine first. When I go and get all my unit circle blend, 2x is what's over here, not x. Or 3x or 4x, whatever there is over here. Not just x because I just undid. He's left. It's time for unit circle. Unit circle, I went looking for, because I was supposed to be finding all the solutions. So unit circle, I'm like, I'm supposed to go to 2 pi. The problem is, I would normally have done, fine, I'm going to 2 pi. But the problem is, when I divide by 2, what used to 2 pi, what used to be sufficient, now needs to be double. Meaning, if I just go pi over 2 and 3 pi over 2, divide by 2, and it's pi over 4, 3 pi over 4, I'm not realizing that there's this whole other cycle of unit circle that got vertically shrunk in to be the same interval. So technically, even though I said, yay, I'm done, divide by, and it's over 4s, I technically wasn't done until I went even further. So to be honest, my advice would be, if you have a 2x, go twice as far. So do pi over 2, do 3 pi over 2 where cosine is 0, but keep going, divide pi over 2. Go 2 rotations of the unit circle, because when you divide by 2, all of this gets fit in to your answers. So now, I have 2 cycles of my unit circle between 0 and 2 pi, and every over 4 is going to be an answer. Okay. Maybe the easier way of thinking about is multiplying by 1/2 instead of dividing by 2. That's not very nice, but and then just in mine, sorry, I made it harder than I probably should have. It was a negative, so I had to go the other direction too. But anyway, I don't think the book even goes that hard. But yeah, inverse trig, unit circle, twice as many. Go to the normal 4 pi. Go twice, because when you divide, then all of those are equal for what you're talking about. So Nathan, one of them, and Nikki, one of those yesterday, I think you weren't even doing individual answers. I think you were just doing plus 2 pi n, if I remember right. So if you're doing that instead, we have 2 different locations. So then, Emma, you would be setting this equal to 2x. And then this one would be just pi n, but if you had written one of the book's shortcut forms, it might even be like a pi over 6n, or it might be a pi over 12n, or something crazy like that. But yeah, if you're doing the infinitely many, it might just look a little differently. Okay. If you guys noticed a second ago, I was like, hey, there are tons of different problems that we could do. I think some of these kind of look like T-proofs, and maybe that makes a little sense as to why they're up here. Some of these have different powers of all. Oh, you get to use a graphing calculator for that. Ooh, quadratic formula for that. They're basically just to help you in weird things that happen in homework. So in these ones, guys, I'm not necessarily going to go all the way. Maybe I'll wait for those kids that are stuck in homework to go all the way to answers on. Can I just give you some hints? Is that okay? I know this hint's going to be helpful in homework, because if you get a sine and a cosine and they're not squared, you're like, how do I? Okay, no, there's a very logical way of doing this one. Where is sine and cosine the same? 45. But you didn't see that. Or in other problems where there might be a +1 involved. In order to get sine and cosine somehow to relate, we have to square both sides. Because only Pythagorean properties, only squares of sines or cosines can be changed to be the other guy. So I need to get squares first. And then Sadie, your question about that square root, just because I know it's coming in homework. If you have something like this, just remember to FOIL it out and not just distribute. But this is the legal way that I can go ahead and get, there we go, a single trig function. Ooh, it's a positive. Bummer, I have to keep going. Absolute value of sine equals square root of 2 over 2 when you rationalize this. And then we would end up doing a plus or minus when we take out the absolute values. That's a unit circle problem. But the idea is if you have a single sine, single cosine, hey, square both sides, because Pythagoreans. Those ones are helpful. I'm trying to think what's weird with this one. This one I think is just a make stuff into fractions to try to get it together, and common denominators, sometimes they just naturally appear, and life is good. Oh my goodness, I should have just done this example. This one would have been a little bit more helpful. Do you guys see how I have the same problem of sines and cosines? But what did I just say to do a second ago? If you have sines and cosines, how do you make them? then you can use Pythagoreans. Okay? Bring in a square. So it's 80 now, you can see what I meant. Because now we have to actually FOIL it out. Pythagoreans make all the difference. Pythagoreans make all the difference. If you have just sines and cosines.
For the top part, is it supposed to be 0?
No, you're right that a lot of them are 0. This just happened to be one where it was 1. But the nice thing is, by multiplying by cosine, eventually I can subtract and get the 0 that I will want when it's time to solve the formula.
I'm supposed to like top one.
Oh, got it. I wasn't filling in because we weren't solving, but yeah, we can do 0 to 2 pi, because I think almost all of them.
Is it always that?
It can change, which is why yesterday I did one of those negative pi to 2 pi. Like it might change a little bit, but I think most of homework is 0 to 2 pi, which is why I did that. And I can illustrate how to finish with this one, just because it doesn't take quite as much factoring and work as that one. Just because some of you, like you're more tuned in today, it's the second day, you're kind of at least getting the hang of it. If we did need to do that 0 to 2 pi, remember, we'd be looking 0 to 2 pi, 1 full revolution. We'd be asking ourselves, when is sine plus or minus root 2 over 2? And whether you're looking at your circle or your cheater chart, hopefully you realize that happens at the pi over 4. And so I would need to steal all the pi over 4s, because plus or minus, that's everybody. So I'd steal pi over 4 and 3 pi over 4. Remember 1/4, 3/4, skipping half, so that's different. 5/4 and then 7/4. Because of my directions, they just want the ones in that one rotation, and that's it. So no plus 2 pi n. If it's just a general solve the equation, they mean all. They mean all. So you're going to have plus 2 pi n's or plus pi n's depending on the context. But this guy, he just wants select few. So I just took the ones that are in one rotation, and I was done. In case that'd be helpful, because I realized we hadn't done one where we finished the whole thing today. Okay, did a hint on that one, sine and cosine squared? That makes things a lot easier. A hint on this one is you do not have to do this by hand. Please, if they say use a grapher, do not try to do it by hand, because you probably can't. It's probably a nasty decimal. So if you're using a grapher, the nice thing is you can just set this dude equal to y1. You can graph him. And guys, isn't there a zeros feature that we can use to find it ourselves? If it's using a grapher, all you gotta do is graph them and find all the x-intercepts. Remember, the zeros are the x-intercepts. That's what you're trying to use. That Precalc graphing handbook, he could be a help if you forgot how to find those zeros. But yeah, if you see something super nasty, make sure you read the directions. Oh, you're supposed to write them. If it says use a grapher, it's not cheating. It's doing exactly what they want. They're saying, hey, these could be solved, at least approximately with decimals, using a grapher. And last but not least, I don't actually know if you have one of these in homework, but if you tried to factor this guy, because it's a quadratic in terms of tangent, I don't have a single trig alone, but if I could factor, I could set each equal to 0 and solve. Is there a problem about multiplying to be 1 and adding to be 3? Have courage. Can I multiply to get 1 and add to get 3? 1 times 1. Nope. How do I factor if I don't have factors? Is my sound on? I'm so sorry. American Red Cross, you don't want my blood. I don't have good iron. I don't even know where my phone is. Hey guys, who remembers the quadratic formula? X equals negative. Whoa, but it's not x squared. It's tangent. Who's squared? X equals, nope. Tangent of x equals, it's whoever's squared. X equals, nope. Tan of x equals negative b plus or minus square root b squared minus 4ac. Come on, finish it. Oh, okay, 2 times 1. Are there answers? Yep. Why? Because 9 minus 4 is a positive number. If it was a negative number, I could say impossible. I could say no solution, and I would be done. If that discriminant, the dude under the square root, reminders, flashback. If that discriminant is negative, fine, done. But sadly, this one's not. So I have plus or minus square root of 5. Ew. Is it wrong? No. Is it unit circle? Definitely. So what do we do? Well, don't box it until you get x alone. But then, right? We can box it. X equals tan inverse. But if the back of the book keeps going, or if they say something about use grapher, couldn't you throw that in your graphing calculator?
Yes.
Your brain might make more sense of it in degree mode than in radian mode, but depending on what they give you, maybe they like radians better. Typically they do. And if it's plus or minus, I have a sneaky suspicion that we might be going in multiple quadrants if you had to think about that. But every now and then there might be something that shows up that's not unit circle, so please go to your calculator. Double check you're right. Maybe you did it wrong, but check the directions. Just because I see that number 50 was use a grapher, so this one very well could have been using a grapher too. All right, guys. Long story short, we've done more practice. We're not done. Remember, we're introducing 5-4, but it's going to hopefully feel lighter. Than the homework. Section 5.3. I'm actually going to introduce 5-4 first so that we can stay in our notes. And then I'm going to go ask people who got stuck in homework where they got stuck. Because to be honest, in section 5.4, all I want to show you is this page. All I want you to write down is this page. Because this kind of sets the scene for the entire rest of chapter 5. Because if you remember, I opened up the book at the beginning of chapter 5, and I showed you at the very end of the chapter formulas. How to use them, how to use them. More formulas, more formulas, more formulas, more formulas. So as you guys are writing down these formulas, please remember there is a formula portion of the test, and we're introducing a lot more that are coming. Don't get lost. Yeah, some of you might be starting to get overwhelmed, being like, oh, she said formula test, that's right, there's the whole blanky thing before the problems. But it's so that we can get the handout of all the formulas for the problems. The test is on 2 different days. If you talk to any honors kids, man, there are a lot of formulas. There are ways to remember these. I'm not going to weigh you down with it today because you're still finishing 5.3. But there are ways of remembering these. You don't really have to memorize 6. You really just have to memorize 3. And those 3, there are some tricks about how to study. At least that work in my brain and work in a lot of kids' brains, maybe not everyone's. But I'll be using them when I recall them. But please remember, whenever you have to do problems, you do not need to be bringing these formulas out of thin air. Have your notes open. Make a formula page. Be looking at the formulas in your book. You do not have to, because whenever we bring them out of like our head, mistakes happen or can happen. And if you're allowed to be looking at them, maybe you'll have ideas that you wouldn't have otherwise if you can stare at all the formulas and say, cosecant is 1 over sine. Might be where you wouldn't have thought of that on your own. So have those formulas in front of you whenever you're doing problems. But now, in this section, we only have to add this one. No, I think there are a couple different sets of formulas in this section. No, it's just these. Sorry, some are different. It's just these. In section 5.5, we have all kinds of formulas coming. But in 5.4, okay, just these. Do you guys see what's below the formulas? It's saying the new ones can be used like the old ones. The new ones can be used like the old ones. In section 5.3, how are we using the old ones to solve equations? Oh, to solve equations. That's section 5.3. How do we use the old ones in 5.2? T-proofs. Verify. Oh, that's this one. How do we use the old ones in section 5. To simplify stuff, to do common denominators with stuff, to evaluate with triangles stuff. Oh my goodness. Like the old ones, aka the basic ones. Old is technically not politically correct anymore, but I think that's only in relationship to people. But these ones, it's the old, prior, former, section 5.1 basic ones. These new ones can be used just like the old ones. AKA, what are we going to be doing in section 5.4? Some T-proofs. Some simplifying stuff and just following the directions. Some solving of equations. In chapter 5, there are really just, this is a huge simplification, but basically there are 3 words. Simplify, verify, solve. And then there are just lots of formulas. 5.4, we get introduced to some more, and we're going to see how to use them, how to play with them. Some little mistakes that get made when you start doing 5.1, 5.2, 5.3 things with them. In section 5.5, it's just like, hey, there are more formulas that can be used. There are more formulas that can be used. There are more formulas that can be used. There are more. Long story short, trig expressions can be changed in so many different ways. But trig, just like a square root, does not distribute. That's the one key thing you need to remember in order to point you to these formulas to use them legally. All right, we have about 5 minutes. Some of you guys are still writing this down. I'm going to freeze the screen for just a second, and I'm going to go find, I don't know, one of those problems that somebody's stuck on in homework. Anybody stuck? Emma, where do you want me to go?
27.
27. If you guys haven't started homework, oh, I'm so sorry. It's okay. Tonight's Thursday. We have a 3-day weekend coming. We can work hard for one more night. Okay. But even if you have started homework, 27, if you want, go to the back of your homework spiral. If you want, go to the back of your homework spiral. You can do it there. You can have it ready for when you do get there in homework. Number 27 has the directions of find all solutions between 0 and 2 pi. Just so we know what types of answers, I've kind of taken a picture that includes it. Number 27. Find all solutions between 0 and 2 pi. My guess is it's a quote.
Yeah.
Okay. All right. And then my outside the boxers, or maybe my just like to have fun with algebra verbs, might divide tangent on both sides because they don't like the cube. The problem is you lose some answers if you do that. The way not to lose answers is to get everything to one side and back to it. If you get it all to one side, all of a sudden, what was super confusing now just turns into, actually you want to be super sensitive. You can technically make this a kind of nasty difference of squares. Or you could have just said equal to 0 and solved with a plus or minus square root. But I believe we'll be going to the unit circle for when tangent is 0, or negative root 3 over 3, or positive root 3. Eventually. Does that kind of make sense? Yeah. And if any of you guys did number 27 and somehow only got some of the answers, you might have divided both sides by tangent, which mathematically isn't illegal to find some answers. But if you divide by tangent, you actually get rid of some of the possible solutions that would come from that tangent. So that's kind of tricky. Who else is stuck? Oh, sorry, I haven't done unit circle backwards. We would go square root of 3 over 3 pi over 6, and it's plus or minus, so all the pi over 6s. So we would have done, to be honest, Kimia, I would have done positive pi over 6 plus pi n to get both the first and third quadrants, and then I would have done plus or minus pi over 6 plus pi n to get those two quadrants. But there's lots of different ways that you could write that. But yeah, there's technically pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6 that all need plus 2 pi n's, or that snazzy putting together version. But don't forget this guy, because it's also when tangent is 0, which is at 0 and pi. So don't forget those extra answers. Because we also have 0 and pi in there. Or 0 plus pi n, which is just pi n. Anyone else stuck, though, about maybe not how to write the answers, but at least how to keep going? Anywhere else in homework? 14. 14? 14, okay, careful. You're just getting You're just doing algebra with trig. So my main objective almost always, and Vanessa, you brought this up, is to get a 0 on one side. But sometimes I have to do some stuff to get there. Don't go dividing sign. Stuff will get so messy. Just subtract it. Because I can think combining like terms. Just think about that being a 1. And as soon as I have that, now this is a much more straightforward unit circle question. But the directions of this one was just solve. And if it just says solve, well, when I do go to my unit circle, and when I do realize when sine is a negative 1/2, I'm going to think of all those coterminal angles. Because I'm trying to answer, if it just says solve, I'm trying to answer with all. But Lucas, the back of the book, oh, it's even. The answer key might do this a little bit differently. It might decide to go negative pi over 6 just because it wants to. But somehow you would need to have both locations and then different tones. Anything else that we're like stuck on, can't get past? Don't know how to get to the answer. Okay. Tonight you might see some weird plus pi n's or plus pi over 4 n's. Some different n's. Come tomorrow if you want, just write the plus 2 pi n's with the answers that you think are right, and tomorrow we can do the whole like, hey, was I right even though it's written differently? Like, we can do that and make sure that you're good. So don't let that totally throw you off and make you think you don't know at all what's going on. Your goal, use your 5-1, 5-2 skills to somehow try to get a trig function alone, meaning also to the first power, or meaning factors equal to 0 and then alone. Get that trig function alone with a number on the other side that can send you to the unit circle cheater chart backwards. And please, please don't try to tackle this one alone. Sound good? Maybe.